Hello everybody! Today I'm going to explain the solutions to the problems A to E from the Codeforces Round 903 Division 3. In this contest we had a lot of different kinds of problems. Some problems were a bit more challenging in terms of implementation, but there were also problems that were full of, let's say, clever ideas without too much implementation. So a good variety overall, although the contest could have been a bit easier on the easy side. So let's begin with problem A. Don't try to count. In this problem, we have a string x of length n and another string s of length m, and we can keep attaching itself over and over when it comes to the string x. And we want to see the minimum number of times we need to do this in order to have x as a substring, in order to have s as part of x. So just like here, let's say if we have ABAA, it shows up as a substring of this string. For this problem, I would say that the most important observation is that we need to make sure that given the fact that the length of the strings is not big, we don't need to actually do this operation many times. And this also allows us to do some sort of a brute force approach. So basically what we can do would be to simulate the process for a few times, at most 10 times, and the moment we get s to be a substring of x, we just stop. If we don't get this moment, we just print -1, and this is what I also did in my solution. So I took part in the contest and I solved every problem. And I just read the strings and I checked using x.find, so using a brute force function, because after all it's a problem from div3. You need to be careful for this problem in order to not run this process for many times, as many people got hacked as a result of doing this. So you need to be very careful at this aspect. Again, a very simple problem, and also very important to know the basics in terms of how to approach it. Now let's move to problem B, 3 threadlets. In this problem we have t test cases, and for each test case we have 3 integers, which are the length of the threadlets, and we want to know if we can get all of those threadlets to be of equal length in at most 3 operations. Again, for this problem there are multiple approaches that can be used in order to get this problem done. You can either rely on a casework approach, you can also use a GCD approach, or the easiest way in my opinion, and this is what I did in the contest, is to just fix the amount of equal pieces we want to have and to simulate the process. Although this takes a few more lines to implement, it's much easier to implement and it's more straightforward. So here we go, let me show you what I did. So I fixed the number of items I want to have. I could have put way less than 20, but I just wanted to make sure that the solution will work. And I checked, of course the sum has to be a multiple of x, and then I just simulated the process, making sure to remove the pieces as I go, as well as also to make sure that I avoid dealing with useless cases. So again, although the solution was longer to implement, it was also much more straightforward, and also I managed to implement it fast enough. So there is this aspect too. Again, another very easy problem, but you once again had to be careful at the way to go by doing it. Now let's move on to C. C was actually, let's say, a problem that was not too difficult from the perspective of its idea, but it was, however, a problem where we, let's say, had to be very careful about implementing it. And the reason why is because there is a certain way to approach these problems where we have to deal with square matrices as well as rotations, flips, and so on. And this is also a very popular kind of assignment that shows up in college courses as well as easier problems, maybe in LeetCode or in other sources. So basically all we need to do for this problem is to reduce the process of solving the problem to each of these four numbers that are, let's say, adjacent in the same path or in the same process. So let's say the number in the corners, or this B here, and this other B, this B, and this B. So they are part of this same square shape thing. Actually, it's this, and this. So again, part of the same shape. And the way we can go by doing this, and I think this is the easiest possible way in my opinion, would be, let's say if we have a certain strip of squares, and let's say we want to start from here. So we know that this is the second square from its strip. So we need to go to the second square from the other strip, the second square from the third strip, as well as the second square from the fourth strip. And given that we know that each of these strips starts from a corner, we can just move these squares along. So this one along the column, this one also along the column, but in the opposite order, this one along the line, and this one also along the line, but in opposite order. So again, you need to be very careful at the process. And also very important, we can deal with each of these separate strips on its own. They are independent of one another until we get to a strip of length 2, which is of course just one of these groups. So again, very important to know to deal with the implementation properly. Also very important to be careful that we can't rotate in the alphabet. So if we get to Z, we can't make it A. Again, very important as well. Also in terms of implementation, this is not very difficult either. You just fix the line, the column, you add the squares that are part of the same group, and then you just fix the letter and see the cost. So you don't even need to optimize this process either. So again, something rather straightforward, but it's very important to think a bit at the implementation beforehand. So yeah, there we go. So we had this problem C. Again, an interesting problem, but also very important when it comes to implementing it. Now, problem D is, I would say, the first problem that had a more difficult idea as part of its process of solving it. And basically for this problem we have n numbers, all of them are up to 10 to the 6. And we have an operation where we replace one number and multiply another number by the same factor. And this leads us to the idea that we can just, so we need to know if we can get every value to be equal. So given the fact that we need to deal with divisors with numbers up to, let's say, around 10 to the 6, as well as the fact that the product of the values always stay the same, it's very easy to come up with an idea that reminds us of sieve. So how we can use sieve in this problem? Actually, we can find for each integer from 1 to 10 to the 6 the greatest prime factor it has in its prime factorization. And each time we get a new number in the input, we can go down the prime factorization to store the frequency at which each of the prime factors shows up in the entire array. And after doing that, we can just check in the end if every single frequency is a multiple of n. And again, these are things that are commonplace when it comes to the C problems, as we have a lot of these kind of problems out there, and it's also very important to know how to deal with them. So at first I did the sieve. I stored for each number its prime factors. I could have made this more efficient, but I just wanted to write it quickly. And after that, I read the input. I kept in a frequency every single value. I could have done it in a more efficient way, but I didn't really care that much as the number of values was small. And this also allowed many suboptimal solutions to pass. So not ideal, but still I show you what I think it's one of the most optimal solutions. Again, this part could have been optimized as well. But after that, I just checked if the frequencies are all multiples of n, and then I printed yes or no accordingly. So again, a very interesting problem, but for someone who knows sieve and knows how to work around the prime divisors and prime factors, it's not that big of a challenge in my opinion. So yeah, we talked about these problems up to D, and we have one more problem we need to discuss, problem E. And for problem E, we have an array of length 10, and we want to see the minimum number of operations we need to do in order to make the given sequence beautiful. Actually, I would say that for this problem, it's easier to think it as the maximum length of the sequence such that every sequence, such that we can get a beautiful sequence. So rather than minimizing this, we can think of maximizing the other way around. So a very common technique, and this also leads us to think at something very important. Basically, the first element from each of these blocks defines the length of the sequence, and we actually don't need to care about what we have in the sequence. So basically, all we need to do is to find a sequence of numbers such that they succeed one another, and we get to the end of the array. And this basically is a DP problem if we think about it. This can be done greedily too, but I don't think greedy will pass. So DP is also way safer. And we can think of something like DP of I to be the maximum length of an array that ends at position I. And we already completed sequences up to that position. And from DP of I, we can go to DP of I plus 1. We don't take anything. Or we can go to DP of I plus V of I. So basically, we can complete a sequence. And all of these, both of these transitions can be done very smoothly in linear time, as we only need to be careful to not get outside of the array. And the implementation will also be very straightforward. Again, we read the array and we just do the DP. We make sure that we don't get over the limit with the values. And we also have to deal with the transition that involves going to the previous position. So again, a very straightforward DP, but again, you need to have a bit of experience with DP in order to see this kind of technique. So yeah, we had the first 5 problems were very interesting, I would say. It was also a rather reasonable contest, as I said in the beginning, although the easier problems were probably a bit harder than usual in the div tree. Again, for F and G, I'm not going to enter into too many details. F is mostly 3 distances from CSS, and for G, you need to work around with data structures, so it's a bit more difficult. But before the next time, I hope you enjoyed the video. Thanks for watching it, as always. And if you like the video, please like, share, and subscribe. And you can also join my Discord server. And until the next time, good luck with practicing and see you next time. Cheers.